Hello and welcome to a new series of videos where we will discuss how we design and build the DCS and PLC systems. In the beginning, you may wonder how this PLC or DCS cabinet, graphics, logics, how they are built. So let's start with the architecture. Let us start with the main system component or the system architecture. Let's start with the field. We have a group of transmitters, on-off valves, control valve, etc. All the data from the field are conveyed to the system through input-output cards. The I/O cards converts all the data from pressure, temperature, and flow and so on into a digital form and send it to all the system components. The I/O card shape and communication, number of inputs, number of outputs, depends on the vendor, each vendor. The data from the I/O card transferred to the next step, which is our controller or CPU. In DCS, we call it controller. In PLC, we will call it CPU. The data from the CPU, all the information goes through the operator through the consoles or the HMI, the human-machine interface. In the HMI on the console, the operator will have a chance to get to see all his alarm, all his variables, and also to put his set points. If we consider that the CPU or the controller is the heart of the system, we can look into three main components in the controller. The first part communicates to the field. The second part communicates to other controllers or to the HMI or the console. And in the middle, we will have our application or our logic. If we look at the hardware, in general, we can see the I/O cards, which is mounted inside the PLC cabinet or in the marshalling cabinet, but sometimes we move them to the field. In this case, we'll call it a remote I/O. Some specialty cards, we will look at them individually in a separate video. All the field cables can go through a marshalling cabinet to be connected to the I/O cards. Then we have a group of controllers, and of course we need communication cards, we need networking, we need power supplies, we need system cables, fiber optic or Ethernet or maybe serial communications. And then our interface to the operators are the consoles and the HMI. A group of cabinets will be required to host all those components. Software is a vendor specific. However, we can recognize three different parts of a software. The first one is required to configure our hardware, like the I/O card, like network switches, your controllers. The second part is where you can build your logic or your PID loops or your start-stop pumps requirement and so on. And the third part is the graphics, where we can build our graphics. If we look at the structure of a PLC or a DCS, we can see there is a network. We can call it the control network. In this controller network, you have all your consoles or you have your controller. Underneath or beneath each controller, you have the I/O cards. So I/O cards are a subsystem of each controller. So if this controller needs to know some data about an I/O card from this card, he has to go up to the network, down to the other controller, and ask the other controller for this data. Another shape we can see, they have moved the I/O card to the network as well. So you can have on the control network, you have the controllers, you have the consoles, you have all the I/O cards. Of course, we need a piece here in this area, which allow us to convert all the data from the input cards to a digital form to the network, and also to convert all the commands back to the output cards. In this scenario, we can see that all controllers has all access to all I/O cards. In the third structure here, we can see they moved all the hardware in the field or the I/O card in the field on a separate, they mounted on a separate field network. Now, this field network is connected back to the control network where you have all your control. Again, this is dependent on your vendor. Each network, or we can call it node, has a maximum number of components. And if you reach the maximum number, you have to create a new node. And then you connect both nodes together to move data between the two nodes. So let's look at from a different perspective. You have the field instrument send all the data to the I/O card. The I/O cards send data to the CPUs and the controllers. And the CPU send the command back to the I/O card. The controllers or the CPUs send the data to the consoles. And then also they send the data to a supervisory level. The supervisory level is there to connect more than one CPU, more than one PLC, more than one DCS in one single spot where you can do a more supervisory level control or data acquisition only. The CPU can also communicate to the business level. In the business level, you have the data, you can have reports and so on. However, you can see here, we don't get data from the business level back to the controller for security reason, of course. So now from the supervisory level, you can have a control command or something go back to the CPU. So this data can move somewhere, but never the other way around. The supervisory level and the business level are not mandatory. So in some cases you will find them, in other cases you may not find them at all. Defining the system component, like the I/O cards, if it is remote or it is local in the marshalling cabinet, you need how many communication cards, how many consoles. All this we will discuss it in details in different videos. So defining the system component, like the I/O cards, we will get it from the I/O list. Then we can separate them based on some rules they're giving us. So that will give us our I/O cards. Now we have the layout. We know if we need some remote I/O. Then we look at how many subsystems communicating to our PLC, like how many HMIs, how many CPUs, how many packages. Then we can know how many communication cards. Then we know there is one control room, to more than one control room, how many operators, then this will give us how many consoles. We will look at each one of these in details in a separate videos. In the next video, we will define our input-output types and we will count them. We know how to count them. Then we will see how many cards we need for each case. Then in another video, we will talk about the cards connection, like the hardwire, how you connect your cards to your inputs and your outputs. A specific video will be discussing the 4 to 20 milliamps type of signals. A separate video will talk about what engineering deliverables you need to design your DCS or your PLC. So thank you and see you in the next video. If you have any question or suggestion, please put it in our